This is the section of Mesra guidelines for safety critical C programming applications. We're looking here at Directive 4.11, and this directive states that the validity of values passed to library functions shall be checked. Its category is required and it is applicable to C90 and C99 variants of the C language. So let us discuss this one. This is one of the directive of Mesra which suggests that even the implementation of the standard C library is not exempted from Mesra scrutiny. So mostly we will wrongly think that uh, C constructions that belongs to the standard C library is exempted, but that is not the case. So you can see from the amplification here that of course this is dependent on the nature of the project, and that nature will determine which libraries and the functions within those libraries should be subject to this directive. Okay, the rationale. Many functions in the standard library are not required by the standard. Here, the standard library is referring to the C library, and the standard is referring to the C programming standard or the ISO IA 1899, which is the definition of the C programming language. This is trying to say that the C programming language does not care or does not check if these input parameters to the function is valid. Let us try to remember that according to Dennis Ritchie, the use of the C programming assumes that the programmer is responsible and old enough to know what he's doing. So this is one of the reason that C is very fast. It does not check for the validity of the parameters, and even if it claims to do the check, you cannot guarantee that the implementation from a specific compiler is doing such checks. You just cannot guarantee that. It is not part or it is not mandated or defined by the C programming standard. And the Mesra guidelines states that the programmer shall provide appropriate checks of the input values of all library functions, and by all meaning including the standard library to refer to the C library. And I highlighted those example C library functions below in green, like square root, log, fmod, to upper, to lower, and C type. And mostly these functions are under math.h or ctype.h, also including the absolute function. Okay, so it is incorrect to think that the C library, which is written in C, is exempted from Mesra scrutiny. In fact, even the C library is part of this Mesra scrutiny, and it will be the role of the programmer to provide such checks. But how will the programmer do these checks? So let's go to the next page. Okay, go here. Okay, although most of the math library functions define allowed input domains, so meaning that, for example, if you call in the square root function, you will not be allowed to pass negative number because square root of negative is mathematically not allowed. So some of these functions define input domains, okay? However, the return value when a domain error occurs may vary from one compiler to another. So if you pass a negative number to square root, you just cannot know how the return value behaves because it differs from compiler to compiler. Therefore, pre-checking the validity of the input is particularly important to these functions. In fact, it is the only way to go here. The only way to work around here is to check the, the validity of the input values such that they are within the domain of acceptable values. Like I said, in the square root, the domain is all positive numbers. Okay. Now, the programmer should identify the domain constraints and so on. Let's go here. So these are the ways in which how to satisfy these guidelines. There are 4 of them. First, the programmer should check the values before calling the function. Second, the programmer should check the values inside the function implementation. And this is only valid if you have the source code of the function, right? Or the supplier of these libraries have some guarantee or can demonstrate some means of guarantee that they did these kinds of checks. Of course, because you cannot go inside the implementation because you are provided with a black box library. The third one is the developer can produce a wrapper function, and this wrapper shall perform the needed checks of the parameters before calling the original function. And lastly is via static analysis. If a static analyzer can demonstrate that the input parameters can never take invalid values. So these 4 action items are the way to go to verify that the input values of functions, C functions, including those functions from the standard C library, are within its domain.